We present interruptible rendering, a novel temporal sampling scheme for interactive rendering. Interactive computer graphics applications must often trade off fidelity for performance using level of detail techniques. We consider this trade-off in terms of spatial error, or how coarse the image is, and temporal error, or how late the image is. Previous level of detail systems have chosen either to seek a constant level of fidelity or a constant frame rate. These correspond to limiting either the spatial error or the temporal error of the scene. For instance, here we use view-dependent simplification to fix the spatial error. The resulting imagery has quite high fidelity, but unacceptable rendering delay, causing broken, chunky animation and breaking the sense of interactivity. Here we render the same interactive sequence, but instead use view-dependent simplification to fix the frame rate to 60 Hz. The result is smooth motion and good interactivity at the cost of a visually coarse model. Interruptible rendering accounts for both spatial and temporal error, resulting in high temporal detail during rapid motion, and high spatial detail when the scene is changing slowly. To evaluate the dynamic visual error of these rendering schemes, we generate the hypothetical image sequence that would be generated by an ideal rendering system able to draw the scene at full resolution with zero delay. We use difference images to measure the error between each rendering system and the ideal imagery. Bright regions indicate higher visual error. Interactive ray tracing is becoming feasible, but raycasting remains an expensive rendering operation. Interruptible rendering is thus especially attractive since it helps manage rendering complexity. Varying the sampling resolution provides a mechanism for progressive rendering to trade off spatial and temporal error. Here is the same interactive sequence rendered at constant high fidelity using a raycaster. And again, this time at a lower resolution for increased temporal detail at the cost of higher spatial error. Interruptible rendering automatically trades off spatial and temporal error. It renders at low resolution when necessary to maintain interactivity, but allows the system to refine to high resolutions when possible. Again, we generate the hypothetical ideal imagery at full resolution with no delay. The difference images once again confirm that interruptible rendering achieves lower overall visual error. In this segment, we show interruptible raycasting applied to a more complex interior model. Our rendering system uses the OpenRT ray tracer on a single processor. Interruptible rendering allows us to make effective use of a ray tracer that would otherwise be too slow for interactive use.